Okay, so what if I told you that everything you think is real, matter, energy, the whole universe, isn't the fundamental stuff of reality? What if it's all just a shadow, an expression of something deeper? We're about to dive into a pretty wild new theory that suggests the universe is built not on particles, but on pure information.
So here's the game plan. First, we'll tackle the big idea behind it all. Then we'll look at what the source code of the universe might be. After that, we'll see how it tries to add to Einstein's equations. Yeah, really. We'll explore how it might solve some huge physics mysteries. And finally, the big one, can we even test this thing?
All right, first things first. To even begin to understand this, we have to be willing to take a pretty huge philosophical leap.
This right here is the heart of it all. See, we usually think of the universe starting with a chaotic soup of matter and energy, and then, somehow, order and complexity grew out of that. This theory flips that script completely. It asks, what if the pattern, the information, was there from the very beginning, and all the physical stuff we see is just a result of that pattern?
The theory has a name, Celominisignum, or the Similarity Theory for short. And its core idea is that the true bedrock of reality is information itself. In this view, order isn't some lucky accident that happens over billions of years. No, it's the starting point. It's the foundation of everything.
So let's be really clear about this. Things we consider fundamental, like atoms, light, even gravity, they aren't the basic building blocks. They're more like the icons on your computer screen. They're just expressions of a much deeper underlying code. The information is what's truly real.
Okay, but if reality is all about information, then what does that source code actually look like, and where is it? This brings us to the theory's model for the universe's deep structure. So the theory proposes this thing called the IEMa, the Informational Ether Matrix array. The best way to think about it is like a vast, invisible scaffolding for the entire universe. It exists at a subplanck scale, which is a fancy way of saying it's at a level of reality so ridiculously small, it makes our tiniest measurements look gigantic. And this matrix isn't made of anything physical. It just holds the patterns, the rules that tell matter and energy what to do.
And this is where it gets super specific. The theory claims there's a single ratio that governs this entire system. It says that for anything stable to exist, whether it's a tiny atom or a massive galaxy, it needs this very specific balance between order and, well, variability. A ratio of about 8 to 5.
You know, it's all about finding that delicate balance. If you have too much rigid order, a system can't change or adapt. But if you have too much randomness, it just falls apart into chaos. But right there, in that sweet spot, that almost golden ratio-like balance, that's where you get the perfect conditions for complex, stable things to form. Things like us.
Okay, I get it. This is all very conceptual, right? A governing ratio. That's a huge claim. But for any physics theory to be taken seriously, it has to connect with the math we actually use. And this is where the similarity theory makes its boldest move. It proposes a direct tweak to one of the most sacred equations in all of science. So on the left, you've got Einstein's field equation, the very heart of general relativity. And on the right, the proposed update. Look really close. The change seems so small, doesn't it? It's just one new term added in there, that little Greek letter psi. But believe me, adding that one little thing changes absolutely everything.
Let's break that down. Don't worry about the word tensor. It's just a math object that describes physical properties. In Einstein's original equation, that T-tensor is all about how mass and energy warp spacetime, which is what we feel as gravity. But this new psi tensor, it adds a brand new ingredient to the recipe. It says that the structure of information itself can also bend spacetime.
And this is the punchline. This is the whole ballgame. Information isn't just some passive label we stick on things anymore. According to this theory, a highly organized pattern can generate its own gravity, totally separate from its mass or energy. The structure of a thing can literally bend the fabric of reality. Just think about that for a second. It means a complex idea, a thought in your head, which is pure information, could theoretically have its own gravitational field, even if it's almost impossibly small.
So what's the point of such a radical idea? I mean, what's the payoff? Well, the claim is that if we start looking at the universe through this informational lens, some of the absolute biggest puzzles in physics might suddenly start to look a lot less puzzling.
Yeah, the theory offers a new take on a whole host of problems. You've got things like quantum entanglement, bizarre stopped light experiments, even the deep mystery of what happens inside a black hole. In every case, the theory suggests the answer isn't some strange new force, but a shared, underlying informational pattern.
Let's just focus on entanglement for a second.
Einstein famously called it spooky action at a distance because he hated it. And we're still kind of scratching our heads about how two particles can be instantly linked across the universe. Well, the similarity theory says there's nothing spooky about it. The particles are acting in sync because they're both still plugged into the same original pattern, the same piece of code in that deep down IEMa.
Okay, this is a seriously mind-bending proposal. But a good story isn't enough in science. For any theory to be legit, it has to be testable. You have to be able to make predictions that can be proven right or, just as importantly, wrong in a lab. So, how could we possibly put this idea on trial?
And that's the billion-dollar question, isn't it? If a complex pattern has its own gravitational pull, totally separate from its mass, how on earth could you measure an effect that has to be unimaginably tiny?
Well, the theory actually proposes a pretty direct and, I think, clever experiment. Imagine you make two objects. They are identical in every way. Same material, same exact mass, same everything. The only difference is on the inside. Object A is built with a highly ordered, patterned internal structure, while Object B's insides are just a random mess. This setup leads to a crystal-clear, falsifiable prediction. If you use our most sensitive instruments to measure gravity, Object A, the one with more internal information, should bend spacetime just a little bit more. If it does, the theory gets a huge boost. If it doesn't, well, the theory is wrong. It's really that simple.
And there isn't just one proposed test. There are others. For instance, you could try growing crystals under two different lights. Both lights deliver the exact same amount of total energy, but one shines a structured, organized pattern, while the other shines just random, scrambled light. The theory predicts that the information in the patterned light will actually sculpt the crystals as they grow, leading to different final shapes and symmetries.
So whether these experiments ever prove this theory right or wrong, just thinking about it forces us to ask this really profound question. Is our reality just a grand cosmic accident, a random collection of stuff that happened to bump into each other? Or is it something more like a vast computation, running on a hidden code where order and information are the most fundamental things in existence? I'd love to know what you think.